Now it is my pleasure to introduce Mike Moran. Mike will serve as our presenter for today. First, a big thank you for joining us. Mike is the Chief Product Officer at SoloSegment, and he is the author of two acclaimed books, Do It Wrong Quickly and Search Engine Marketing, Inc. Mike led many initiatives on IBM's website for 8 years, including IBM's original search marketing strategy. He additionally serves as a senior strategist with Busine, a leading social media consultancy based in New York City. Mike holds an advanced certificate in market management practice from the Royal UK Charter Institute of Marketing and is certified as a distinguished IT specialist by the Open Group. He also writes for Search Engine Guide, Biznology.com, and various other blogs. Mike is a certified speaking professional and frequently keynotes at conferences worldwide on internet marketing for marketers, public relations specialists, market researchers, and technologists. He's a professor of professional practice. Try saying that one. Professor of professional practice at Rutgers Business School and a visiting lecturer at the University of Virginia. I've gotten to know and adore Mike through his work as a program faculty member for several of our Mini-MBA programs. And with that, Mike, I'll hand things over to you to get started.
Terrific. Thanks, Margaret. I'm going to hand things over to you to get started. Let's start with a poll. Let's find out how many people out there are actually using AI already and to what extent. So, Margaret, if you could jump that poll up, there you go. So, are you extensively using AI or just in some areas, or maybe you're just doing some pilots or just starting, or maybe you're planning to do it next year, which is why this webinar was on your radar, or maybe you don't have any AI plans yet, you're trying to figure out how to get them. So this is really what we want to know. I'd like to know what the audience is doing here. So we're going to go through an awful lot of stuff over the next hour, and I'm going to go through it pretty quickly, but you'll see at the end that there's actually a course coming up at Rutgers for how to use AI in business, and a lot of the material that we cover here will be in that course. We'll go over it a lot more slowly and with a lot better a lot more chances for you to ask questions and actually put it into practice. So hopefully you'll join me in that course, and we'll be talking more about that at the end of this webinar. So I think, Margaret, we've got enough answers here that you could share the results. It looks like people are doing it in some areas is the major thing, and number two, yes, we're using AI in some areas, and there's a bunch of people that don't have any AI plans at all, and so that for both of you, this should be pretty interesting, because what we're going to do is we're going to talk to you about what kinds of AI there are and what kinds of things you would need to do to be ready for different kinds of AI. And so that's what we're going to dive into right now. So if we ask ourselves, what is artificial intelligence? The thing is that there's a lot of definitions out there, but this one I know is true because I read it on Wikipedia, and it says, the ability of a computer to perform tasks that usually require the intelligence of the human being. And you know what cracks me up about this definition? This is actually the definition of artificial. It's like the hard part is figuring out what intelligence is. And so what I really want to think about is, what is intelligence? That's what's hard, right? We know what artificial means. Yeah, a computer does it. But the thing that we really want to know is, how do we know something's intelligence? And actually the truth is that the bar keeps moving, that there's a number of things that a few years ago we thought were artificial intelligence, and now maybe we're not saying they are anymore. And so artificial intelligence is kind of anything a computer does that kind of surprises us that it can do. So that's a pretty arbitrary definition. So the thing I want to focus on here is not on being absolutely clear about whether something's artificially intelligent or not, or whether everybody else will think it's artificially intelligent. What I want you to think about is, are you ready to automate things in your company that use techniques that people consider to be AI, And are you going to get benefits from it? How do you know you're ready, and how do you know you're going to get the benefits? That's really what we want to talk about. So let's talk a little bit about the kinds of AI. So when you see in movies that there's some kind of omniscient power out there that is controlling the world, those are fun movies, but that's not really what AI can do, at least not now. And so that's something called artificial general intelligence. And what it really means is that a computer can go toe-to-toe with a person in trying to solve any problem that there is. That does not exist. I'm not sure that's going to exist in my lifetime, but I'm old. Maybe you're a lot younger than me, and it'll come around at some point. The thing that is here now is what they call narrow or weak AI. And even though it has those names, what it really means is that you can create an AI model, and they usually call them models rather than programs, even though they kind of are programs. But you can create an AI model that can solve a problem in a single domain better than a human being. And you can see we've got a few bullets up on the board here. Basically, the famous ones that have happened have been taking on human beings at games. And so there have been a number of things where they beat human beings at chess, at Jeopardy, at Go. And so these things have popped up periodically through the years. They've caught attention, but these are just examples of things that maybe everybody can relate to. And so what's really interesting about AI is that it can do better than a human being at some narrow types of problems. And so the question is, do we have the kinds of problems in our organization that AI can solve, and are we ready to apply AI and solve them? That's what we're going to talk about today. So, but a lot of people get spooked by AI. And if you're one of those people, I really want to talk to you first. So there's all sorts of things that people worry about. So they look at these things happening, that computers are doing this and computers are doing that, and you know, what does this leave people to do? And so you can see some of these things here that says, you know, simple sports and stock price articles are written by robots. So if it wasn't bad enough, if you were a newspaper reporter, now you've got this to worry about too. Within 10 years, 40% of today's Fortune 500 companies might not exist. And these things sound terrible, but the truth is that this is what happens all the time. And that's what we really want to think about. I mean, if we took an example from 1790 and said 90% of the U.S. population was farmers, and then 200 years later, 2.6% were farmers, but we didn't have 87% unemployment because, you know what, people found something else to do. The thing is that we as people are usually pretty bad at predicting the effects of technology. We're very good at being scared about what the changes will be, but we're not that good at understanding what the benefits will be. In the 1920s, experts predicted that the growth in phone usage would require all women in North America to become switchboard operators. Now, if you can get past the sexism there, that obviously, how could men do this kind of job? Only women can be, you know, if you can get past that. What happened instead is that we invented self-dialing, automatic switching. Technologies came in that meant that we didn't have to do that. And so we're really bad at understanding how things will automate it so people don't have to do things. We also get really nervous when that happens because they're like, well, what do people find to do as a job? And so basically it's a personality test. You can think that AI is going to bring us much more leisure time, or you can think that it's going to leave us all unemployed. What I'd like to point out is those are actually the same outcomes. It's just a question of whether you're an optimist or a pessimist. And so what's really going to happen is that we'll find other things to do that are at a higher level that computers can't do. That's what we've always done. And so it used to be that people were hired because they were good at adding and subtracting, and there were all sorts of jobs for people who could do that. Well, we don't need that anymore. That's what calculators and computers do. Doesn't mean that everybody who was doing that is now out of work. Now, it also doesn't mean that this is going to be easy for everybody. You will have to adjust. Because people do worry that AI is going to take their job. What I'm here to tell you is that for most of the people on this call, AI will take your job only if you're the person who refuses to work with AI. And I think that's really the message here, is you personally need to be ready for AI, and we also want your company to be ready for AI. And so how does narrow AI work? Do you think that Deep Blue really was out thinking a grandmaster, or Watson knows more than Ken Jennings? It's not really what's going on here. What's really going on is that computers solve problems differently than people do. And so we want to make sure that we're not ascribing to a computer actual human thought. That's not what's happening. What's happening is that a computer can kind of brute force its way through all sorts of things so much faster than a person can, that a computer appears as though it knows a lot more than people do. And what's really happening when we talk about how computers learn is that AI allows a computer, when it gets enough data, to start solving problems better than it did before. So let's talk about that. A traditional program, a piece of software that a software programmer develops, basically is a set of instructions. It says, if this happens, I want you to do this. Then I want you to go through every record in this file and add up the numbers in this column and tell me what the total is. Then what I want you to do is, if that total is higher than last month, I want you to put in the report that we were up. And I want you to do a subtraction to say how much we were up, right? So those are all instructions. A person could do exactly what the computer does if you just gave the person the same instructions that you give the computer to do. I call this do what I say. AI is different. An AI model actually is told to deliver a result. It's told, here's an example of answers to these questions based on what the questions are, and what I want you to do is to answer more questions like those. And so you're not actually telling it how to do it. And so that's very different from a traditional program. And so how does AI deliver a result? Well, let's use an example. So you can think of Photoshop as being a traditional program in the way it's being used. Because if you think about what's happening, you as the user have to tell Photoshop what to do. So you have to tell it to change the gradient here and make the lighting look a little different here, and maybe use some tool to get rid of some shadows over here, or maybe you're going to Photoshop somebody out of the photo that you don't like, right? So, but you have to know how to do that. You have to be highly skilled. So Photoshop can do all these things, but I have to tell you, I can't do those things with Photoshop because I'm an idiot when it comes to Photoshop. I don't know how to do those things, so Photoshop for me is useless because I can't give it the right instructions. Now, on the other hand, I can use an Instagram filter all day long. I can flip through the pictures and I can see which one I think looks best and I can post it, because that isn't using me as the expert, that's using the software as the expert. And in fact, they used to call AI expert systems. And so all I'm asking it to do is to deliver a result. When I see the result I like, I'm done. And so that's a way for you to think about the difference between a traditional program and AI. A traditional program, you have to have the expertise to know how to solve the problem to write that program. But in AI, you don't. You just have to give it enough examples and know when you have what you're looking for. And all of a sudden, it can find the pattern and be able to answer questions on its own. So one of the jokes about AI is, if you know how it works, it's not AI, right? So if you knew how to give it instructions to solve the problem, well, you're not actually using AI. And so that's really what we want to talk about here. But there's another thing we want to talk about, too, that's different from traditional programs. With a traditional program, if you give it the same input every time, it will give you the same output every time. So the outcomes for that program are going to be exactly the same if you give it the same input. So if you ask it the same question, it's going to give you the same answer. If you give it the same data and it's supposed to do some operation on it, it'll give you the same result. In fact, if it doesn't do that, that's called a bug, and you need to fix it. Well, AI is very different from that. And one of the reasons we talk about machine learning, which is probably a term you know, the learning part of that, is that AI actually resembles a human being in some ways, because if I gave you the same task to do 100 times in a row, you would get better at it. you would suddenly start to be faster at it, more accurate at it. You might be giving better answers the 100th time than the first time. And so AI has that quality. It actually improves the more data that you give it, the more examples of correct answers that you give it, the answers to questions it hasn't seen start to get better. And so this is why we talk about machine learning. The computer isn't actually learning in the sense that we learn as human beings, but it appears that way, because as the computer gets more experience with the problem, it does a better job. And so that's the difference between traditional software and AI models, is that you get better outcomes the more data that you give it. But as I mentioned before, what we consider to be AI keeps changing. So I was actually, when I was at IBM, and when I was at IBM, I spent a lot of time in IBM research. I retired from IBM a few years ago as a distinguished engineer. So I've been working in AI since the 80s. And in the late 80s, we actually put together a linguistic search engine. So if you looked for the word mouse, we knew to find the word mice, because we knew it was the same word. And we could do that in 33 different national languages. And so everybody said, oh, this is the most interesting AI we have seen in search in so long. But about 10 years later, when Google did spell check, nobody said, wow, look at Google with that AI engine. They didn't say that at all, because it became normal for computers to understand language the way that human beings do, to know that certain words mean the same things as other words, to know forms of words, to understand when we made a spelling mistake and what the right word should be. Those were things that over that 10-year period in the 90s became kind of normal. And so even though we thought of them as AI when we did them, people weren't surprised by them anymore. So we no longer were discussing them like, hey, look at, do you see this AI? That's what's happening all the time. So it's always changing. So you shouldn't worry too much about whether something actually is AI or not. What you should worry about is it solving the problem? So it's not about getting computer science awards. It's about making sure that your business is making better decisions and operating more efficiently. That's really what you want to focus on. And so the difference for how AI changed was it went from kind of a rules-based approach, the way traditional software programs do, where you say, if this, then do that, here's the flow chart for how that should work, to something probabilistic, where it says, if you see a certain condition, that makes it more likely that this is true. But it doesn't mean if you see this, then it's true, which would be something that's very different from that. That's the way traditional software programs work. And the first time I actually came across AI was back in the 80s, as I mentioned, and there was a problem that we were trying to solve that I had not been able to solve with traditional rules-based approaches. And so this probabilistic approach was one that we put to work. And the project I was working on was actually an IBM product where what we were trying to do was to send news stories that were personalized for the person reading them. And so one of the things that we wanted to do was to send news stories to people in the travel industry, where they would then want to read different stories every day and keep up with their industry. And we had this terrible problem where all the news sources we got, so for like wire services like Reuters and AP, the problem we were having was that we couldn't distinguish the personal stories about travel, so here's where you should go on vacation, from the industry stories that says, hey, we expect vacations to go up, and so we're expecting that people are going to be going on more vacations next year than this year. And so those are two different kinds of stories. The industry people didn't want to see the personal stories, but when we tried to look at all the words, we could not find any words that distinguished them until we brought out an AI model. And the AI model was looking for patterns. Here is the pattern that it found. The word you is all over the personal stories. It's written in the second person. It's written to give you advice, whereas the industry stories hardly ever were. The industry stories were written in third person. The only time you found you was when it was in a quote. And so at that point, we could then distinguish the stories. But I have to tell you, we had librarians working on this for months, and they never thought of this because it's not a way a human being would think. But it is a way a computer would analyze a pattern. A computer doesn't know that it's silly to think about whether the word you is there, which is what we did. The computer looks at everything. And so it found exactly what we needed to do to solve that problem. And that's really how AI can find the answers to problems that are staring humans in the face, but they don't actually see it. Now, the reason that these things are happening, and the reason that AI is really taking off, is because of data. And so I need to present to you the single most boring slide presented to a business audience. This is about something called Moore's Law. And what Moore posited back in the 70s is that transistor density will double every 2 years and costs go down by half. And maybe you don't know exactly how you would put this to work in your everyday life, so let me explain a little bit more. What it really means is that it costs almost nothing to hang on to data. And we can collect more and more of it because computer chips are faster and because disks are so much cheaper. So for example, I'm not sure if you could have amassed 8 gigabytes of memory in 1970, but if you did, it would have cost you $3 billion with what the price of disk was back then. But this is actually the amount of disk that you can hang on your keychain for $2 today. And so this is a tremendous change. And so this has enabled artificial intelligence because data is the fuel of AI. And so what's happened is this enormous upheaval where data that we never thought about being able to collect and store now is simple and cheap to collect and store. And in fact, I've actually played a trick on you. It isn't true that it's $3 billion to 2. The reason is because I didn't take into account inflation. In today's dollars, it's actually 20 billion to 2. And so here's the thing, right? If you had any other area of business that had changed this much, you would have like a car that came with a single tank of gas that lasted for its entire lifetime, right? So there's no way of thinking about this in any kind of way that makes any sense to us. And so what we just have to do is to roll with it. So if you think you're not keeping up with all the technology changes, you're right, you're not. Human evolution didn't prepare anybody to be ready for stuff like this. And so what we want to do instead is have you think about what kinds of changes need to happen in your business so you're ready to collect and store and use in AI all of this data that's available to you. And so if you think about big data, which is what the catchphrase is, then there's basically 4 elements to that. There's volume, that's the big part. You probably figured that out. There's velocity, which is how fast the data comes in. There's variety, which means we collect different kinds of data all the time, right? I mean, a few years ago, nobody was collecting shares or likes in social media because social media didn't exist. And so the type of data keeps changing. But the place where you come in, the place computers are really not going to do a very good job, is that last V, veracity. What can you do with the data? Can you trust it? What decisions can you make on it? Is it accurate? What are the things that you would allow to decide based on that data? And what are the things that you're like, I don't really know if we trust it for that? That's things that people need to do. You need to do that. And that's not going to change anytime soon. So let's look at ways of assessing your readiness for AI. So there's actually a number of different ways to use AI. So a lot of the people who in our first poll question said, we're not using AI yet, yes, you are. You just don't know it because you didn't have to do any work. That's embedded AI. So commercial off-the-shelf software where AI uses generic data across all the clients, you didn't have to do any data, you didn't have to do anything. AI just showed up in the software product that you're already buying. Everybody's got that. And so you might think you're not using AI, but you actually are. And guess what? You don't need any readiness to be able to take advantage of that. There's nothing you need to do. Now, data-driven is a little bit different. It's probably still off-the-shelf software, but you might need to figure out how to prepare your data to be able to put into a model so that it will actually work for your problem, because your problem might be different from another company's problem. Specialized is where now you suddenly need data scientists. Specialized means that you have to create your own AI model. And so that's a very different undertaking, and it's usually this specialized approach that people are thinking of when they say, we're not ready for AI yet. We don't have any data scientists. We don't have people who understand AI. But you might be able to do data-driven. You definitely can do embedded. Custom is one that hardly any companies need. Custom means that you're actually inventing new AI techniques. So if you're in software research, or you're an AI company, or you're Google or Facebook, you're probably doing custom. There's probably no one on this call that needs to think about that. And so let's think about this. So embedded is something everybody can use. So guess what? You're ready for AI as long as it's embedded. And so if you can just find software that has AI techniques in it, they will probably be solving problems better than software that doesn't have those AI techniques in it. So let's look at an example. So a spam filter. I would be shocked if there's anyone here who's using an email system who doesn't have an AI component in the spam filter, if it's not using machine learning. I'd be really surprised. So, because almost all of them are. And so the email vendor that you're using, Google or Microsoft or whoever it is, they're going to train an AI model across all the companies that are working with them. So you don't have to give them your data. They have the data already. You don't need a data scientist. You don't need to train any models. The vendor, the email vendor, is going to do all of those things, and you don't need to do anything except buy their product. What about data-driven? What's an example of this? So Margaret mentioned that I'm the Chief Product Officer at SoloSegment. So we have a data-driven AI approach that will make your search engine better. So how does that work? Well, your search engine on your website probably suggests words as people are typing and says, hey, I think this might be what you want to search for. The problem with those algorithms is they often suggest words that maybe come up with no results or come up with bad results. And the reason is because the algorithm is just looking at what's popular. What did other people search for before without really thinking about whether they found what they're looking for? So what we do at SoloSegment, one of our products, has this ability to know whether people found what they're looking for in your website search. And so what that means is we can pepper that information into the suggestions. So there's all sorts of machine learning that can go into understanding whether people found what they're looking for and then trying to show them words to search for that they will be successful for. And so this data-driven approach means that there's an ability for your site search engine to get better if you allow us to collect the data. So we can put a JavaScript on your page, and it'll collect all that data that will help us know if it's being successful or not. And so you have to buy the product, but you also need to be willing to provide the data. Now, for some data-driven approaches, you might need an IT person to actually do some work to collect the data out of a database somewhere. But for others, like this one, you just need to say to the vendor, it's okay that you can use our data. But data-driven is a little different, because if you saw that with the spam filter, there wasn't anything to do. But with this, there might be something to do. And so the question of whether you're ready might be based on whether the vendor is going to collect the data like we do in this case, or if you have to give them data that you've collected, and do you have a person who's capable of doing that? What about specialized? Well, here's another example from our company where it's a way of recommending content. So what has happened here? Well, we use the same information about whether people are being successful on your site, and we look at the content and we recommend it. Now, Now, in this case, it's actually fairly easy to be ready for this, but there's a lot of cases of specialized where you might have to build your own model. In this case, as your vendor, we would build the model for you, but we're building a different model for every client that we have because they have different content, they have different patterns of what things are successful or not, and which content is actually the content that's correct to recommend. And so this is an example of a specialized model where we need to get a data scientist involved in order to build a specialized model for your company. So you could have a vendor that you hire that does that, or you could do it yourself with your data science team. But this one is different from the previous one because the previous one had the same model for everybody but different data. This one has a different model for everyone, so it's a little bit harder to do. And this is what most people think of when they're asking themselves if they're ready for AI. Do I have a data science team? Do I have AI experts? Can I collect all the data? And so that's what we want to think about. Now, hardly anybody, as we said, needs custom. You probably don't. If you do, and you need to ask me some questions in the Q&A, go ahead, but I'm going to skip past custom because hardly anybody needs it. Now, you might need specialized, right? Everybody is going to be doing embedded. Most of you are probably already doing data-driven, but you don't realize that you are. But specialized, where you have to hire a data science team, where you have to build your own models, that's something that we're going to talk about. How would you be ready for that? And so the first place to be ready for specialized is with your big data. What is all the data that you have? And most of the time, you probably have a lot of data already. The problem is it's hard to access it. The problem is that it's in silos. So every operational system is creating its own silo of data. So your marketing automation system is dumping data somewhere. Your CRM system is dumping data somewhere. You've got all sorts of other systems that are dumping data. You've got a financial ledger that actually knows when people paid their bill. And so if you're trying to figure out, hey, how do we target the customers that are least likely to stiff us after we've done the work for them, you'd need the marketing automation system, the CRM system, and that financial ledger to all have their data available so that you could put that into a model. But you probably don't have that data easily available. Every different operational system has its own data format, and it's very, very complicated. And so the reason it's complicated is because each of those operational systems has something called a schema to their database. And what it basically means is it's a roadmap to the data. It's something that says, hey, we know what is stored in the tables. We know what columns are what. We know what those column names mean. So what is the definition of the data? So a database has a schema. You can think of a flat file spreadsheet as having a schema as well, right? Because there's rules for what goes in each column of a spreadsheet. And so, and you often have to link from one spreadsheet to another or one database table to another in order to really make sense of something, like you can see in this example on the screen. So you might, for example, have a code number for a particular branch office, and you won't know what branch office that is unless you look up the code number in some other table to find out what the city of that branch office is. And so these are the typical ways that data is stored, but every operational system has its own schema. And that's what makes it really hard, is that for someone to solve the problem that we laid out that crosses these silos of data, they have to understand the schema for each of those operational systems. And some of them don't tell you what their schema is. You bought this software, it stores the data, it doesn't tell you. In that case, you might need to use ways of dumping the data into a spreadsheet, or you might need to use an application programming interface, an API, to be able to get the data. All of those things are things that make it much more complicated for you to do. And so what's happened is that all sorts of problems exist. And Margaret, I'd like to ask people if they have these problems in their organization. So if you could launch the next poll, I'd like to ask if people have siloed databases like I just described with all these operational systems, and definitely pick more than one answer here. pick all the answers that are true for you. So you could pick all 6 of them if they're all true for you, but if they're not, just pick the ones that are true for you. And so, do you have fractured data ownership where different parts of the organization own the data? Do you have inconsistent definitions of the data where it could be that you've got a serial number in one database and a serial number in another database, and in one database the serial number is the serial number of an employee, and the other database it still says the word serial number, but it's the serial number of a machine that you sold. And so do you have different data definitions, maybe even with the same name? Do you have inconsistent quality where you don't really trust the data in that system as much as you trust the data in another system? And maybe you have duplicate data that some places you want to pull the data from this one, and others you want to pull the same data from something else. And that leads to difficulty of accessing the data. Do you also have difficulty securing the data because you've got so many systems that it's hard to make sure that only the people that should see that data are actually getting access to it? So definitely love to see the results here. Boy, it looks like we've got a lot of problems out there. So sorry to hear this, folks, but yeah, it looks like everybody's got this problem of siloed databases, 3/4 of you. And the other problem that most people have are fractured data ownership and difficulty accessing the data. We got a 0 for securing the data. I got to tell you, I bet if you've got siloed databases, you have difficulty securing the data, but it's probably just not your problem. But the other problems, they were all over 33% as well. So these are all things that we have to cope with, and this is what it contributes to you maybe not being ready for AI. And so what is it that's having to happen here? So as we mentioned, you might have different systems that call fields the same name. You might have different things that are called different names for the same thing. You might have different data definitions or sources from different versions of the truth. So you might have sales that you get from your web analytics system for everything that people dropped into their shopping cart and bought, and you might get sales from the financial ledger, which also includes taking out sales for things that people returned that your web analytics system doesn't know about. And so all of these things might give you different data that seems like it should be the same. And so what have companies done to try and solve this problem? Well, one of the things that they did was to create a data warehouse. So they pulled data from all these operational systems into one place, and they made sure that it was consistent and up to date, secure, accessible, and the benefits of this approach are just undeniable. They're just huge benefits. The problem is that a lot of times the benefits are unattainable. And the reason is because it's extremely costly to create data warehouses. They take years to do in a large company, and even after you're done, it's too hard to use the data because there's one huge schema that has all of these complications in it, and you need to understand that schema in order to do anything with the data. The other thing that's a problem is if you suddenly want to add a new kind of data, you're going to break the schema, and you might have to redo the schema work before you can pull anything new in. And so people went to another thing to try and solve some of those problems. The problem of making it easier to use, they actually split things up into more silos. They created data marts because they pulled together data that might be useful for different types of problems. And so that's what they tried to say. Well, what if we pull data from this silo and that silo and that silo, and we put that data together? That'll be easier for a person trying to solve a particular type of problem. But what happened then is that it's an easier way to feed the users, but the other problems remain. So let's launch another poll. This will be our last one. And does your organization have any of these things? So does it have a data warehouse? Does it have data marts? Does it have a data lake? And we haven't talked about it yet, but does it have a data science team? So who's got these things? Because if you have these things, you're probably ready for AI to solve at least some of your problems with those specialized approaches where you're having a data science team that's pulling the data, or you're hiring a vendor who has a data science team who can solve your problem by creating a custom model. And so, Margaret, I think we can end the polling here. We've got a few answers here where it looks like almost everybody's got a data warehouse. Some of you have data marts or a data lake. Over half of you have got a data science team. And so you're ready to solve at least some problems in AI. And so from a data point of view. So that's something we really want to make a checkbox on. From a data point of view, you might be ready. But then another question we have is, do you have a problem that you can really solve with AI? And that's something that we want to ask now. So the last thing that we're going to talk about before I throw it open for questions is, how do you know you have a problem that you can solve for AI? That's a more complex discussion that we can't really get through in a couple of minutes that we have left. But what we're going to do is I'm going to give you an example of a problem that one client brought to me that we tried to help them solve. So they had a committee that was approving all new web pages that went on their site. So changes to web page. So it had the lawyer there. It had kind of the branding committee to make sure that the brand was being done properly. They had a sales team to make sure that they were, and a support team to make sure they weren't putting out things that were going to, cause the support line to get overrun. And so there was all sorts of things that they did. But they had a committee that was doing this, and the problem is that they were very slow. The committee only met once a week in order to do approvals, and the people on the committee were very high-level people, and this was the most boring part of their job, and they hated it. And so they asked, hey, can we use AI to replace the committee? Could we train some AI model so that we could not have to use this committee, and then the AI model could run whenever somebody submitted a page? And so we said, okay, let's look at that. Well, the problem with that is that in order to do that, what you need is to have collected a lot of data about what has happened in the past. They hadn't done that. And so they didn't have a record of the pages that had been approved or rejected in the past. They didn't have any type of storage of any of that information. They didn't even have a standard that said these are the things you have to do and these are the things that you can't do. They just were using judgment to do this. And so they didn't have a process that was standardized. They weren't collecting the data. They didn't have any of the things that you would need to feed into an AI model to do this. And so how would you know if you have a problem that you can solve this way? How do you avoid the problem that they had? Well, to pick a good AI opportunity, it should be an important problem. That means that you ought to have some type of business case devoted to it. And I even see a question that's asking about business cases. We'll talk about that during the Q&A. You need to have a well-defined process. It needs to be something that operates now with human beings in a pretty standardized way. And you need to have outcome data. What's outcome data? Well, in the situation we talked about, the outcome data was what was the decision of the committee for a page, who rejected it, and what was the reason that it was rejected, and what was the part of that page that caused that to be rejected. And so in order to get that kind of data, you need to be collecting it. And there's two types of outcome data. One kind of outcome data is human agreement. The other kind is objective metrics. So if you've got human beings that agree that this was the right outcome for this situation, then that can be very good training data. But you could also have objective metrics. You could have metrics that know the answer. For example, if you were trying to use AI to recommend better content, well, you might know how many people put products in their shopping cart after the recommendations. And so you've got an objective measure that says something's wrong or something's working. And so what was it in this case? In this case, it was human agreement, right? You needed to have a record of what all the human decisions were of previous pages in order to have something for the AI model to train with. And that's really what the answer was, is that they needed to do this. They eventually abandoned this project because they didn't want to go to the trouble of collecting all the data. They didn't think that the business case was worth it. But if they had been collecting the data all along, they might have been able to go forward. And so one of the ways to be ready is for you to understand for your problem, what kind of process do you need? What kind of data collection do you need? how do you make sure you're collecting the data that your AI model will need to use? So that's the end of the webinar. I know I went through this stuff really quickly, but guess what? I'll go through it really slowly in part of this Mini-MBA on artificial intelligence. Now, we run these classes regularly. The next one is in late April. And this one is a virtual class, but, you know, post-pandemic, we're hoping that you can come in person as well if you'd rather. And so the URL that's on your screen is exactly where you can go. Even if you're watching this webinar on a recording a year from now, you can go to that URL and see when the upcoming classes are. And this is not an AI class for data scientists. It's not for people who want to learn more about AI. It's about people like you who want to know how to apply AI to your business. So I hope I'll see some of you there. So Margaret, that's it for us. I'd like to throw it open to questions.
Great presentation, Mike. And even though you moved fast, I actually enjoyed that. I was, keeping up with everything. So I appreciate it. We do have one question in the Q&A, and you made a little bit of reference to it before. How do you get started, and what are your suggestions on building a compelling business case?
Sure. So we mentioned a little bit about how to get started, right? So one is to pick a problem that's really important, right? And if you're going for that specialized type of AI where you need to collect data, you need to put a model in place, you need data scientists, or you need to hire a vendor that's doing that, these are not inexpensive things to do. Right? If you're trying to do something embedded, you just have to find software that solves the problem really well and buy it. If you're trying to do data-driven, that's not quite as expensive either, because you can buy a product that has a model in it already, and you might only have to do a little bit of work in order to get your data to be available to it. And so those are things that absolutely you could do, and maybe you wouldn't need such an all-encompassing business case for it. But if you're trying to do that specialized approach, it's going to take time, it's going to be expensive, and it's risky. It could fail. You might not be able to solve the problem. And so what you really need to do is and you create the business case the same way you would create it for any other type of automation problem. What are the benefits? Is there a benefit to the answer to the question coming faster, or more accurately, or at scale? Or is it answering a question that helps you make a decision you have no data to make a decision on now, and you're expecting your decisions will be better? What is the impact in the business of those better decisions? So there's nothing really different about the business case for AI than for any other kind of software. But what we really want you to think about is how will you focus on what the cost side is. So the cost side is either you're buying some software or you're paying a vendor for something, or it might be internal costs of having a data science team and an IT team pulling data. And there's also the opportunity cost. Is there a more important problem that those people could be working on that they're not because they're working on this one? And so those are all kind of standard things that every business case needs to take into account. So I hope that helped.
I'm sure that did. Thank you, Mike. We have another question about being a new company and wanting to use AI. So how do you collect and organize a new company's data into one silo so that it can be fed into an AI model? And how much historical data do you need for the AI model to function properly?
Got it. So those are two different questions. The first one's actually pretty simple. There really isn't any difference whether you're a new company, small company, large company. It doesn't make any difference. The way that you collect that data together from the operational databases is as we showed you. You could use a data lake is one technique. You could use a data warehouse. Those are both different techniques. The third thing you could do is you could just dispense with both of those, and every time you have a problem you're trying to solve, then you just focus on pulling the data out of the existing silos. So any of those can work, and I've seen them all work. It kind of depends on what it is that you're doing in order to know what the right thing is to do. Now, in terms of how much historical data do we need for AI to function, that's a very different question. And I wish that there was a simple answer to it, but there isn't. So it really depends on the situation that you're in and what the problem is. So one thing you might do, if we have time, is maybe you could post a follow-up question for exactly what the problem is, and if I have some expertise in that area, I might know. You can also email me afterwards. We'll show my email address at the end. I'll say it now. It's mike@mikemoran.com. But that is something that that you could email me about, and I might be able to help you with some answers. And in fact, anybody who wants to email me with any question, mike@mikemoran.com. Even if you're looking at this as in a recording, just send that to me. I'll be happy to answer your question 2 years from now. Just remind me that you were on the Rutgers webinar, and I'll do my best. Now, if you send me 5 questions in a week, I'm going to try and send you a consulting engagement. But if you're nice to me, I'll try and answer any questions I can, even years from now. But how much data you need for an AI model to function depends tremendously on the data. So for the kinds of problems that I work on every day at SoloSegment, we find that having a couple of weeks of collecting activity data on most websites is enough for it to really start to work. We work with mostly larger companies that have, thousands of people coming to their website every day. So after we get kind of like, 10 business days of data, usually things are starting to work pretty well. But if it's a smaller company, that could take a much longer for something like that to work for that problem. The problem of having enough data to know when people are finding what they're looking for and where they're finding their answers to specific questions. So for that problem, it would take a couple of weeks. There might be another problem. For example, if you were trying to predict sales, then you might need several years of sales data in order to have a good prediction, because you'd need to be able to take into account seasonality. You'd need to be able to take into account different types of economic ups and downs, and those things might all be part of your model when you're trying to predict the future of where sales would go. And you'd probably be looking at kind of your sales pipeline in your CRM system. And so it depends on what the problem is, how much historical data you need. We worked with a company that it was actually trying to do contact management, where it was recommending to salespeople which people to reach out to in their contact list and how often. And we found that we only needed a few months of data in order to be able to solve that problem. And so some of it has to do with how important the problem is and how much better the solution is to what you're doing now manually. So in the case of that salesperson contact recommendation system, the system they had already was terrible. They were recommending things, but only about 12% of the recommendations were things that the salespeople acted on. Over 80% of the time they looked at those recommendations and said, "Those are stupid. I'm not reaching out to him. Why would they tell me to reach out to him?" And with only a few months of data, we were able to get the salespeople to be reaching out to 75% of the recommendations. And so because it was so starkly better, they only needed a few months of data. Now, if on the other hand, they had a system that was working 80% of the time, and we took a few months of data and got 75%, they would have said, "That's no good. Sorry, that isn't better than what we have now. How much more data do we need before this starts to work 90% or 95%? Because that's the kind of improvement we want to see." And so some of it, so it definitely depends on the problem, but it also depends on how well you're solving the problem now. How long will it take for AI to have enough data to solve it better?
Great response, Mike. Thank you. We had a question that came into the chat rather than Q&A, but since I saw it, I'm going to ask that one now. Is there a way to measure or rate the maturity of an AI model?
There is, depending on what kind of model it is. Most AI models are doing what are called predictions. Sometimes they're classifying things. So, for example, the company Busine that I work with, they actually do sentiment analysis, among other things, for social media listening. And so what they do is they use human judgment to help them know when something is positive or negative or neutral, and they can actually judge whether things are accurate or not. And so the way they do that is they measure things against what the humans say. And so they take all sorts of tweets, for example, that a number of human beings have agreed are positive or negative or neutral, and then they test the AI system against those very tweets and see how often the AI system agrees with the human beings. And so that's actually a way for you to test the accuracy of an AI system. You can also test whether it's getting less accurate over time, because that frequently happens with AI systems, is that you train them, and then some aspects of the data that you trained it on have changed in real life, and you haven't retrained it. And so then it starts to atrophy in terms of its accuracy. And so now you need to maybe retrain it. So there are systems that allow you to sample the data and show you levels of accuracy as things change over time. That can help trigger you to say, hey, I think we might need to add more training data. We might need to update the training data, retrain the model, and see if we can get back our own level of accuracy. And so those are all ways of understanding kind of the effectiveness of a model. And as models mature, they tend to become less accurate unless you maintain them. And so assessing the maturity of a model, it sounds like maturity sounds like it's always a good thing. It isn't always a good thing. And so you really need to measure effectiveness of the model. Maturity just kind of means that it's been used for a long time. And so what you really need to focus on is whether it's getting better or whether it's getting worse. And so focusing on those types of questions are kind of the business maturity of it, which I think is really what the heart of your question was.
Great response. Wow. Thank you so much, Mike. We've run out of time, and I'm happy to say the only questions remaining are mine, and I know how to find you. So I'll ask those at a later time. But again, thank you for your time today and a fantastic and thought-provoking discussion about artificial intelligence. And thanks also to our audience. They were enthusiastically participating in all those polls and in chat and Q&A, and it certainly enhanced the dialogue around organizational readiness to embrace and use AI. And a friendly reminder to everyone listening that RBS webinars take place on Wednesdays at noon Eastern, and we hope it's easy for you to remember in the middle of the week and the middle of the day. For more information, you can always visit our webpage, and I'm going to say it, but this is mostly for the people who are listening to this as a recording, because everyone else will receive this via email, business.rutgers.edu/alumni/lifelong-learning. And we encourage everyone to stay online for just a moment longer to complete our survey. It's very brief, and one of the questions allows you to type in topics and or speakers you'd like to see featured in our future webinars. And finally, as I mentioned when our webinar began earlier, a link to the archived recording of this presentation will be shared via social media and email to registrants, and it will also be on the Business Insights page of our website. And with that, we are done for today. I thank everyone and wish you a good rest of your day.